One thing I can say, and that was that the quote that Ted Happold always used to say, that one of the most important things was that the design process should be enjoyable. And there are obviously certain tasks which computers can do which are very helpful, particularly if used in the right way. So something like email, for example. So the first project I worked on, we were able to email drawings, was the British Museum. So that was very nice. It meant that Philomena and Russo at Foster's and I could work together, sending drawings backwards and forwards. Whereas in the past, you either had to go, you had to be in the same office basically, or you had to rely on the post, which was obviously quite slow. So that was good. On the other hand, as everybody knows now, in any sort of business, you get this sort of email overload where everybody thinks that they can send all sorts of crap to all sorts of people, and you get all this stuff. So I suppose the thing is to try and preserve the aspects of the work that you enjoy. For an engineer, for example, or an architect, you enjoy drawing with a pencil, sketching ideas and things. And it's obviously nice to be able to, say, scan those and send them to your friends or do it on an iPad or something. And so that's obviously great. But then what you want to try and do is to not lose those aspects that you enjoy. And yes, I suppose there's all sorts of issues in that, and that in the sense that there's also what happens with your, or how you see your career progressing. One of the problems is that if you're successful, then you end up basically not being an engineer or an architect anymore. You end up being a manager. So I think it's important that to try and strike a balance there. But that's where teamwork comes into it. And again, with Ted, one of the good things about Ted was that he was very good at delegating, and also very good at choosing the right people to work with him so that he could delegate. I think at the moment there is a bit of an issue with a generation gap, in the sense that young engineers, your sort of age, they're all sort of good at things like Grasshopper and stuff like that, and Revit and what have you. Whereas older engineers don't really understand what on earth you're talking about. But I guess that problem will continue, because you probably know about Revit and Grasshopper, but in 20 years' time, probably those will become out of date. And there'll be a new generation of young architects and engineers who have this new stuff, and you won't understand what in the hell they're talking about. So it would take you a whole day to design a portal frame, whereas now you do it in 5 minutes on some software. So it was nice to see that change taking place. Also, it was quite nice that, to begin with, there was very little software available. So you ended up having to write your own software. And that was quite good as well. So that was nice. So it meant that on projects, say the Great Court, that because there wasn't software available, we wrote our own software, which is much more satisfactory than using off-the-shelf software. When I say it's satisfactory, more enjoyable. You feel as though you're more involved. I think now we're sort of reaching the stage where a number of things are sort of coming together and making things more difficult. Maybe that's just, I think it is, certain things are more difficult. Architectural geometry, for example, if there was something complicated with the geometry of a building, then they used to get the engineers to do that because they were good at maths. But then once computers came in, architects realized that perhaps they needed to get quite up to speed on all this maths and computing. Because obviously it's very important for the aesthetics of their building. So something like architectural geometry is somewhere in the middle. It's not really, is it architecture, is it engineering? But again, this is not a new thing, because if you go back to, say, do you know what stereotomy is? Yeah? Stereotomy? I suppose the difficult thing is that every time a new grid shell is built, it in some ways reduces your choice, because you don't want to just repeat what somebody else has done. Yeah, I guess grid shells will be with us. Well, we've had grid shells for, how long do you reckon? 200 years or something. There have been many steel and glass houses. Yeah. And there's been things like the Grand Palais in Paris and so on. Mm. So the idea of covering a public space in such a way that you have a lot of natural daylight is something that people naturally want to do, at least in the temperate regions and cold regions. Okay. Yeah. Yeah, so I guess grid shells probably are here to stay. I suppose the strange thing is that the biggest one and the most challenging one was the one that we did first. Yeah. Of the timber grid shells, the more recent ones have been less challenging. What happened on the Multihalle is that there were originally other engineers for the project. And I don't know exactly what happened, but they felt that they couldn't really cope with the project. And so Frei, who met Ted Happold in Saudi Arabia, I think, suggested to Ted that we might like to be the engineers at Arup in London. And Ted said, yes, okay. Very brave of him. And so he turned up in the office one day and said that we've got this project in Mannheim. And so we had various information. We had, I think at that stage, Frei was already building his hanging model. Mm-hmm. And Linkwitz was doing the computer model. Yeah, yeah. But we didn't have all that information. So to begin with, we built a model of the Essen grid shell, which Frei had done earlier. Yeah. And from those model tests, we were able to show that the original design for Mannheim just wouldn't work. The original design just had one layer. In other words, members going in, just two sets of members like that. Hmm. And so we immediately said that we had to go for a double layer. In other words, two sets of members in each direction. And we also added cable bracing. Yeah. And all of that came from the Essen model, which is a fiberglass model about 1 meter across. Mm. For some reason, engineers and architects seem to struggle scaling model test results. Yeah. And I'm not quite sure why. Physical models are still quite useful because they give you a very tactile feedback as to how a structure is working. Yeah. Yeah, so we used those scale model tests, and they showed that we could just about get it to work. Mm. It was interesting talking to the people at Arup then, because there were the original generation of people. So we had a meeting. So Ted and I had a meeting with Arup himself and Ronald Jenkins to discuss the project with them. We also talked with John Blanchard and all the sort of technical people at Arup to discuss it with them. People who'd worked on Sydney Opera House, for example.
Yeah.
So, yeah, so that was quite interesting. And as with all projects, there's lots and lots of detailed day-to-day stuff that you have to do. Like we had to there was no CAD in those days. So we had to find ways of doing drawings of curved arches and things like that. We had a little desktop computer which you had to write programs in, and then it was sort of had this. It would then print out sort of strips of data which you then work out and put into your drawing.
Yeah.
So all that was quite fun. So I guess the big change in terms of computers was between then, in the mid-70s, early 70s that was, and then British Museum, which was the late 90s, by which time we had desktop computers and stuff. So the geometry of the British Museum was done on a Macintosh Performer, which was a home computer from the mid-90s. Yes, but it was very exciting, and I was very young then, and so it was good fun going with Ted or Ian out to Stuttgart to see Frei and the other people at the IL. I guess you've been to the IL.
Yeah.
Yeah. So in those days, it was out in the countryside. It wasn't surrounded by all those other buildings.
Yeah.
Yeah, so that was all good fun.
Yeah. And in the document, you mentioned that was something related to grid buckling in timber, which was one of the major challenges you faced during construction. Yeah.
Yes. If you're doing a slender structure which works in compression, then buckling is always an issue. And in some ways, the more perfect the structure, the more it's an issue, because then the more perfect it is, the more imperfections influence its behavior. With timber, though, the big problem is that you don't really know what the stiffness is. That if you apply a load to it long term, you get a lot more displacement than you do in the short term. To a certain extent, the same thing applies to concrete as well. And creep buckling is where the structure moves over time, becomes more and more imperfect. And as it moves, you get more and more bending moment. And so it creeps more and more quickly. And so it's pretty bad news. But you have very little information as to the creep behavior of timber, which is understandable because you can't do tests that last 20 or 30 or 40 or 100 years. People always say that timber is very sustainable and you should build everything from timber. But it's I think when it comes to using choice of structural material, you want to use what is most appropriate for the particular circumstance that you have, taking into account all sorts of factors, including how long the building is going to last, and so on, and taking into account energy in use as opposed to energy used in construction and that sort of thing. But material choice is always an interesting topic, and it is partly an engineering decision and it's partly an aesthetic decision. And obviously taking into account things like sustainability and so on.
Yeah.
The most important thing is that if you're interested in something, then be prepared to teach yourself. Because there are so many possible things that you might be interested in knowing about. And the chances are that there won't be anybody at your university or whatever it is who is perhaps interested in that subject. And that doesn't matter, because especially now because so many books and so on are available, is that you just sit down and teach yourself. Of course, the problem, as I think I've already said, is that you don't really know what will be useful. But I guess the thing to do is to start with the things that you think are interesting and inspiring, and then work from there.